Okay, the first topic session is about fecal microbiota transplantation for livestock animal well-being, which will be delved by our speaker, Dr. Jahidul Islam from Tohoku University. Also, session will be led by our moderator, a lecturer from Department of Agricultural and Biosystem Engineering. She is Putrika Cita, Master of Science. Let me read the moderator's CV for you. So this is the CV of our moderator. The moderators in this session is Putrika Cita Pramesi, Master of Science. The last education is Master of Science in Food Technology, Ghent University, and KU live in Belgium, right? And the last is the third international and smart and innovative agriculture, Yogyakarta, Indonesia, as a collaborator in paper presentation. And the last publication is safety assessment of indigenous probiotic strain Lactobacillus plantarum that 13 isolated from daddy using sperge rats as a model. Don't have any longer, Putrika Cita, Master of Science, the time is yours.
Can you all hear me clearly? Okay. Thank you, Miss Indah and Miss Halim. So good afternoon for all of the participants joining us virtually, also on site. My name is Putrika, and I am a lecturer from the Department of Food and Agricultural Products Technology here in Universitas Gadjah Mada. And today I will be your moderator for the first session. So we are now in today's main event, which is the lessons or classes. I reckon that most of you all are getting sleepy after the lunch break. So feel free to lightly tap your cheek, not too hard, just for you to freshen up. And maybe those on the Zoom, you can take a break and maybe grab a cup of chew to freshen up. So joining us is Dr. Jahidul Islam from Tohoku University. So for this afternoon lesson, Dr. Jahidul Islam will be presenting his research about a very interesting topic, which is the fecal microbiota transplantation, or FMT, for livestock animal well-being. I believe Dr. Jahidul Islam is present virtually in Zoom. Good afternoon, doctor. Maybe you can turn your video for a while, if it's possible. If it's not, then or maybe say hi. Okay, I think his mic is muted, but let's give a round of applause first to our first speaker. So Dr. Jahidul Islam has prepared a recording of today's lesson. But beforehand, I would like to briefly introduce our esteemed speaker. Maybe we can open the CV first. Yes. Okay, so Dr. Jahidul Islam is an assistant professor from the Graduate School of Agricultural Science, Tohoku University. He obtained his master in biochemistry and molecular biology from University of Dhaka, Bangladesh. And in 2017, he received his PhD in nutritional biochemistry from Tohoku University, Japan. He has published numerous articles about gut microbiota and nutrition in respected international scientific journals. His expertise including microbiome, bioinformatics analysis, and animal model studies. So without further ado, let us start the first lesson. To the committee, can you start playing the video, please? Thank you.
Hello, everyone. Welcome to my talk. I am Jahidul Islam. Currently, I am working on Graduate School of Agricultural Science, Tohoku University, Japan, as an assistant professor. I am very happy to join this sixth summer agroindustry summer course, and I am very honored to give a lecture on my research. Basically, I am continuing my research, especially on host microbiome interaction. For example, fecal microbiota transplantation in large animal, in which today that I will speak today about this. Beside this, I am also involved in other projects. Particularly, I am also investigating single cell RNA sequencing to investigate immunoglobulin A. So my topic is fecal microbiota transplantation for livestock animals' well-being. Particularly, I will speak about not the big size cattle, but the pre-weaning calf. I think is our human starting from our human civilization. We have always dependent on livestock, right? This relationship has endured through the ages and will continue to the future. So to ensure a good quality of life for even human, we must maintain a strong we must maintain and promote the well-being of livestock practicing for good animal care is essential for our mutual benefit. So currently, livestock sector is key driver for sustainable development in agriculture. They contribute food security, nutrition, and provide elevation and economic growth. According to Food and Agriculture Organizations, livestock contributes about 40% of the global value of agriculture output. Livestock supports the livelihoods and food and nutrition security of almost 1.3 billion people. Ruminants like cattle, sheep, and goats convert forage and rough-phase byproducts and non-protein nitrogen into meat, milk, and wool. And the major livestock farming is the cattle farming, pig farming, sheep farming, goat and rabbit farming. The role of livestock in meeting human food needs. So globally, animal proteins contribute about 39% of total human edible protein. For example, milk and meat we receive from the livestock. Meat is a valuable source of high biological protein, iron, vitamins, as well as other trace element also. Milk is a popular drink for human, and for example, milk, especially from cow milk, is a very rich source of protein, minerals, vitamins, which are very important for bone formation, growth, and disease prevention. So we need to increase the meat production. So the world meat production is expected to increase about 41 metric ton carcass weight, equivalent to estimate 382 metric ton CWF by 2032. Although the most of the growth will be occur in Asian region, and the highest maybe for poultry farming, but if we combine other livestock like beef and pork, it will also increase by 20 metric ton CWE. So the animal-based food energy demand, if we check the demand of our next 50 year, so we will find that the consumption of these animal proteins has must be increased um, in recent years, as well as with a growing interest in overall protein consumption. And this market will be expected to rise significantly. And when the long-term projection reveals that especially the upper middle income countries will increase the demand of this animal-based food source by 2040. Maybe after that, the lower middle income countries will lead. So overall, basically, this animal-based food energy demand is high. So from our previous slide, so we can understand we have a very good demand for livestock, but the livestock sector is still facing some challenges. For example, environmental issues like the livestock industry is a significant contribution to greenhouse gas emission, deforestation, and water pollution. And the production cost is also increasing compared to previous time. The feed, labor, energy costs have been increasing. So this is especially those are small scale farmhouse, they are facing this production cost, and this production cost is also increased by the disease and technology adaptation. There are also challenges in adopting modern technology to improve the efficiency, growth, and disease prevention and in livestock sector. Disease outbreaks. Livestock are very easy to infect some infectious diseases, especially uh, the disease can increase or can spread very rapidly. In recent times, for example, avian influenza or foot and mouth disease, or even well-known swine flu is a very serious public health concern for originated from livestock sector, and those have also incurred a loss of a economic burden. And the recent times, the most talk is about antibiotic resistance, especially the overuse of antibiotics in livestock is using in very very rapidly. But this uses of excessive antibiotics also increase the rise of antibiotic resistance bacteria. So antibiotics overuse a major challenge in livestock industry. The overuse of antibiotics in livestock is seen to promote growth and prevent disease in animal. The overuse of antibiotics in livestock can have several serious consequences for not only for I think animal but also for human, and it's a very big public health concern, as well as the environment. Uh, Overuse of antibiotics in livestock can lead to the development and spread of antibiotics resistance bacteria. So these bacteria can survive and multiply their number despite the antibiotic treatment. So we need to develop alternative options beyond the overuse of antibiotics. Like we can introduce probiotics, prebiotics, vaccine, as well as other new way of treatment. For example, fecal microbiota transplantation. So from now, I will exclusively talking about my main topics, basically, especially in the cattle farming and their diseases and how we can manage the diseases without using antibiotics. Cattle farming is the practice of raising cattle for various purposes, um, and it's an important industry worldwide, and it's started this industry about 1,000 years ago. So calf farming is a critical aspect of livestock management, focusing on their breeding, their rearing, and their health care to ensure their growth and their well-being. So, what is pre-weaning calf? So, a pre-weaning calf is a young calf that has not yet been weaned from its mother's milk or milk repressor to solid feed. Um, This pre-weaning period typically spans from birth until 6 to 8 weeks of age. Although the exact duration can be can be different depending on management practice and the specific needs of the calf. However, the pre-weaning period is very critical time for calf as they have high chance to bacterial or viral exposure and to occur diseases. So what are the most common diseases in pre-weaning calves? Especially, for example, diarrhea, pneumonia, and septicemia. These are the most common diseases the calves are exposed in their early stage of life. Introduction to calf diarrhea. Calf diarrhea is a commonly reported disease in pre-weaning stage. It is still a major cause of productivity and economic loss to cattle production. It is about 39% of calf mortality is caused by diarrhea during the first 3 weeks of life. So this disease can vary by geographical location of the farms, farm management practice, and herd size. Symptoms of calf diarrhea. So the major symptoms, they have the water loss and they have water epiphysis, and their eyes are shrunken eyes, very weak and inability to stand, and the final stage is death. The major causes of diarrhea, but generally diarrhea is a multifactorial disease. It can cause by infectious factor or non-infectious factor. So infectious factor basically occurred by three major pathogens like bacteria, virus, and protozoa. So among the bacterial cases, Salmonella, Escherichia coli, and Clostridium perfringens are the major pathogen causing this diarrhea. In virus cases, especially rotavirus and bovine coronavirus are responsible. In protozoal cases, Cryptosporidium parvum and Coccidia are the major causes of diarrhea. In non-infectious factor cases, basically linked to the farm condition. For example, farm hygiene status, number of calves, and seasonal variation, especially in winter season, this the diarrheal incidence is increased. Common recommended treatment options for calf diarrhea. As I said before, calf diarrhea is a multifactorial disease. Both bacteria, virus, or protozoa can cause this disease, and in multiple pathogen can cause this disease at the same times. For example, primary viral attack like rotavirus can facilitate the small intestinal overgrowth of E. coli. So in turn, it increases the morphological damage of the small intestine and cause diarrhea. And to treat this, the major treatment options are antibiotics. And in antibiotics cases, first choice is basically parenteral ampicillin and ampicillin combination. Some doctors also prescribe analgesic and anti-inflammatory agents and some steroid drugs or even some non-steroid drug also. So to treat calf diarrhea, we have introduced another option that's called fecal microbiota transplantation, FMT. So what is fecal microbiota transplantation technique? Fecal microbiota transplantation is the transfer of feces from a healthy donor into a diseased person, basically. For example, in calf diarrhea cases, we collect healthy fecal sample from a healthy calf that we call donor, and we process this fecal sample and we transfer this fecal sample to a diarrhea calf, and it is cured after few days and it becomes healthy. So the recipient is become healthy after FMT. So what basically FMT does? The primary purpose of FMT is to restore a healthy and balanced microbiome. FMT increases beneficial bacteria and it decreases pathogenic bacteria in the recipient and enhance immune function. So talking about fecal microbiota transplantation, we have to understand the microbiome concept. I think many of you have idea about microbiome. So I will give a short description of microbiome. The microbiome basically is a complex community of diverse microorganisms like bacteria, virus, bacteriophage, fungi, protozoa, etc. All are collectively known as microbiota that inhabit a particular environment in animals and in humans. And depending on the position of the microbiota, we give the name. For example, those bacteria are found in the gastrointestinal tract. We call it gut microbiome. In human, there is about 100 trillion of microbes live in human body, and among them are 95% basically found in gastrointestinal tract. And this is an image of human feces, basically. So what is the importance of microbiome? The most important of microbiome is in our body to digest food, because the microbiome helps to break down the complex carbohydrate fiber that human body cannot digest or cannot uptake directly. So the microbiome break down this complex carbohydrate structure. Microbiome can produce short-chain fatty acid. Short-chain fatty acid like butyric acid, acetic acid, and propionic acid, which serve as an energy source in the intestinal cell, and they have anti-inflammatory activity. Microbiome regulate immune system. So the gut microbiome is essential for development and maturation of the immune system and promotes a balanced human response. Defense against pathogen. So a healthy microbiome acts as a barrier against harmful pathogen by competing them for resource and producing antimicrobial compounds. And metabolic functions. Microbiome helps to uptake essential nutrients like vitamin B or K. So by uptaking this and in food digestion, they helps to produce energy that very important for our survival. So microbiome, even though microbiome has some positive effect, but in some time microbiome has some negative effect. For example, microbiome can cause dysbiosis. So dysbiosis is the imbalance of microbial community, in where the harmful bacteria number is increased, but the beneficial number is decreased. So when this number is changed, we called that the diversity is become going down. So when the microbial diversity is going down, there is a high chance of occurring diseases. And another negative impact of microbiome is pathogen overgrowth. So in general, when the beneficial bacteria are short, for example, due to antibiotic use, the pathogenic bacteria number is increased. And biofilm formation. So when this pathogenic bacterial number is become high, they can form biofilms, which are more protective, these biofilms provide the protection of the pathogenic bacteria. So as a result, it's very tough to prevent or to reduce this harmful bacterial number by using antibiotics. And finally, immune dysregulation. So obviously, when the microbial diversity is become lower and the high number of pathogenic bacteria presence in the body, they have changed the immune system. As a result, the diseases become severe, which can finally initiate the autoimmune function in the body. So the microbiome has always a positive impact in our body. However, we cannot omit their negative impact in some various reason. So I reintroduce again FMT, as I said before, the technique of FMT. So now you may think why I will consider FMT over antibiotics. So here I have shown some major difference in implications of FMT and antibiotics. For example, their mode of mechanism is different. FMT generally restore the microbial diversity by increasing beneficial bacteria and decreasing pathogenic bacteria. But antibiotics generally kills the bacteria, both harmful bacteria. Along with this, they also kill beneficial bacteria. In FMT, FMT generally target in a large number of microbial community. But antibiotics is sometimes non-specific and they target a very few microbial community. Resistance issues. So if we use repeated FMT, they are effective in antibiotic resistance bacteria, but antibiotics are not effective in antibiotics resistance bacteria. And in overall, their impact on gut microbiome. FMT basically promotes a healthy and diverse microbiome. But in antibiotics, they can sometimes disrupt the microbial community and they can cause dysbiosis. So now we can understand the major difference between FMT uses or antibiotic uses. But maybe in animal sector, the uses of FMT is still in early phase. Maybe you have heard that uses of FMT in human cases. However, we cannot use the FMT result from human to animal. So the difference, there is some difference between animal and human FMT cases. Especially, for example, the microbial composition is different between human and animal. The pathogen pattern is different. And environment and management factor in human and animal. In animal cases, the uses of FMT is little bit still highly challenging because the animals live in a group and they have a high chance of disease transmission. So introducing FMT in animal cases should be highly regulated with safety action. The donor selection system is different between human and animal. So now we have, I think, now we have idea how FMT is differ from antibiotics, and FMT uses in human is different from FMT uses in animal. So FMT procedure for calf diarrhea treatment. So now I will describe the method for FMT procedure. Donor selection. The first step of FMT is to select donor, healthy donor. And generally, some pathogen test is required for identifying healthy donor. The healthy donor must be disease-free, antibiotic uses-free. After selecting the donor, we have to collect fecal sample, and based on our choice or methodology, we can process the fecal sample on the same day, or we can store the fecal sample at -80 for long after uses. So how we can prepare FMT? So the step 3 basically describe the donor sample preparation. So the fecal sample should be mixed with some liquid like sterile saline or PBS to make some fecal slurry. In the meantime, we have to find out the recipient suffering from diarrhea. The step 5 is administration method. Generally, in orally or rectally, FMT is given. Although in human cases, both options are available, but in animal cases, basically rectally is given priority because it's very easy to insert. And after finishing FMT, step 6 is that post-procedure care. So we have to monitor the recipient calf for any adverse reaction. And we have to give them normal feeding and care. And we have to observe the clinical efficacy. So if the disease is recovered and the diarrheal symptoms is gone, we can say this FMT is successful. Our latest FMT research. Now, the contemporary FMT transplantation generally focus on farm-specific manner, in where donor and recipient are selected from the same farm. Generally, farmer or veterinarian doctor like this approach because if the farm practice and farm management or pathogen transfer can occur farm to farm. So to avoid this violence type pathogen transmission, generally donor and recipient are selected from same farm. But in our latest FMT study, we have overcome this challenge. We have successfully shown that donor can be selected from different farm or even different region. So to do so, we have collected fecal sample from 150 healthy calf from 3 different regions of Japan named Hokkaido, Chiba, and Okinawa. So you find out that these 3 regions are totally different and they are far from each other. So from these 150 healthy calves, we have selected 24 best donor and we gave them name as universal donor. So now the method is arise. What is the purpose of making a universal donor? So we have made some definition. For example, universal donor is an individual whose fecal microbiota consists eager or expected to be bring positive health outcomes for a large proportion of FMT recipients in all areas of different farm practices, management, and geographical locations. And what is the characteristics of the universal donor? So they have very high microbial diversity. They have presence a specific bacterial strain, beneficial bacterial strain, and this calf has lead a healthy life and they have no antibiotic uses and pathogen and antibiotic resistant gene. So if you see this figure, this is the healthy sample fecal microbiota. This red means Chiba, yellow means Okinawa, and green means Hokkaido. So the 3 different region healthy donor. So from this, we have selected 24 healthy donor. So more specifically, we have collected, as I said before, we have collected donor from 3 different area and we transfer this donor fecal sample to 3 different region of diarrhea sample. For example, the donor from Hokkaido is used not only in Hokkaido, they are also used for recipient in Chiba and in Okinawa. Same pattern is followed, for example, for Okinawa sample cases. In Okinawa donor is not only used for Okinawa recipient, but they are also used in Chiba and Hokkaido. So we call them cross area FMT intervention. So how we make that? So when we collected fecal sample, we have separate fecal sample around 10 gram, and we keep them in each vial, and we have freeze dry them. So freeze dry is the procedure of removing water in the fecal sample. So after freeze dry, we store the donor sample in the refrigerator as -80. So we have make some bank, fecal donor bank. Study design. So in this slide, I will show how we design our study. In previous slide, I have explained how we select the donor. So in donor cases, after finishing their selection, we store them in refrigerator, as I said before. So in this time, we have to consider another thing about the time point. Generally, we have collected healthy donor sample at September and October, and to process the donor sample at November. And in late November to December or January, this is the winter season start in Japan, and in winter season the diarrhea cases, number of diarrheal incidents is increasing, is common. So the donor sample that we already selected are ready for FMT transplantation in this time period. And for selecting the recipient, we have select 24 recipient sample from 3 area: Hokkaido 24, Chiba 24, and Okinawa 24. In total, we have collected 72 diarrheal sample, and from 24 donor, so that means on donor, from one donor we make at least three vial. So same donor sample are sent or transport to 3 different area. So one donor is used for 3 areas, as I said before also. Okay, so when we perform FMT, before FMT we have collected blood and feces sample. So blood is generally taken for understanding the systemic changes, and feces sample is checking for pathogen test, gut microbiome test, and metabolite test. And after FMT, we have collected fecal sample again at day 1 and day 7. At day 7, we also collected blood and feces, and to compare the microbiome changes before and after FMT. Generally, in our study, we have used 7-day period to evaluate the clinical efficacy of the FMT. So if the diarrheal sample or feces condition is not improved, then we call it failure. And if the diarrheal symptoms is gone, then we call it successful. So this 7-day we have taken this FMT intervention. So, this is some typical picture of the fecal condition. This is we call normal fecal, and this is a loose, this is muddy, and this is watery. So based on this score, we have identified successful or failure for. So a score of 3 or 4 basically indicate diarrhea, and 1 and 2 basically indicate healthy. So when we perform FMT, we said we perform 72 FMT. So among the 72, we have found 55 successful FMT. So our total success rate is about 76% and failure is 24%. And when you check the diarrhea score below 2 in successful cases is below 2, but in unsuccessful or failure cases, this level is increased. So in our FMT, cross area FMT intervention, we have find out 76% success. Now we have checked the FMT efficacy based on donor. You have already known that we have used one donor for 3 reasons, 3 area. I mean, then among the donor, about 46% donor is successful in 3 area, and 42% donor are successful in 2 area. In 8% donor is successful in only 1 area, and only 4% donor are not successful, they are failed. So there is a chance that same donor can be successful in on area but can be failed in another area. So what type of microbiota change by FMT? When we discuss about the principle of FMT, we said that FMT as well as FMT increase the beneficial microbiota. So when we compare our result, we have find that Proteobacteria, a major phylum of gram-negative bacteria, those basically responsible for diarrhea, they are decreased after FMT. Oh, okay, so I will describe the result, these figures. This figure indicates the major phylum changes, and this is the first one is donor. HOK donor means Hokkaido donor. CHI means Chiba donor and Oki donor. And 017 means the 0 means the day 0 before FMT, and 1 and 7 means day 1 and 7 after FMT. So we have shown the result based on the donor as well as recipient, and among the recipient day before and after FMT. So if you think this is the HOK donor means they are healthy sample, and day 0 means they are diarrheal sample before FMT, and day 1 and day 7 after FMT. So if you look closely, you will find that the Proteobacteria level is going short, or I mean going low compared to before FMT, and is almost same as healthy donor. And this phenomenon is similar to in these three donor cases. So that means the FMT changes the microbiota and they have lower the pathogenic bacteria and they have make their microbial composition same as the donor. So in the context of FMT, changes in Proteobacteria basically indicate an important marker for microbial and clinical success. So this scenario is basically for successful FMT cases. So if we consider how the FMT works for well-being of calf diarrhea, we will find some major aspects. Number one, FMT restores gut microbiome compositions, and FMT reduces the recurrence of diarrheal symptoms. And after changes this microbiota and disease recovery, they have helped to enhance nutrient absorption. We have checked the blood parameter. I'm sorry, I did not include the blood parameter result in where we found that FMT increase the total cholesterol level after FMT. So that means the total cholesterol in blood indicates the healthy status or nutrient availability. So we found that in successful FMT, the FMT helps to enhance nutrient absorption. So if we find out that this FMT works in these three major concerns, so obviously FMT reduce the antibiotic uses. So this phenomenon is found without using antibiotics. So this is an overall FMT principle. So if we want to say something about in short slogan or short line, maybe we can say that FMT provides a more holistic approach to managing diarrhea, addressing the root cause rather than just symptoms. The overall health and well-being of the calves improve, leading to better growth rates and productivity. So, how FMT can be formulated? Now the question is arise how we can make the FMT very available for the field. Still now, especially in human cases, there are several formulation and manufacture procedure for making different types of donor microbiota preparation. For example, in Jain et al. Shown that they have introduced capsule formation. This is for human users, so it's very non-invasive way. So for that, at first they have isolate the microbiota and they have freeze dry the microbiota, and after that they have make some capsule. So this is a one example of FMT formulation. Although in human cases there are several protocol established for donor FMT preparation, still in animal cases only few studies are introduced to manipulate or to design a new types of FMT formulation. However, there are many ways to be considered. For example, fresh FMT or fresh FMT means this is for donor sample. So fresh donor sample or frozen donor sample. In animal cases, in our FMT research history, in our first FMT study, we have used fresh sample. That means at the same day, we have collected donor sample and we start procedure and we transfer them to the animal. But in our latest FMT research, at first we have collected fecal sample, then we have sent them to the laboratory, then we have freeze dry and we have make them frozen. So what is the difference or what is the advantage or disadvantage of fresh or frozen FMT formulation? In case of fresh FMT, fecal sample is collected from a donor, processed and transferred within a short period of time, especially within 24 hours. And it has some advantage. So the best advantage is this has higher microbial viability and diversity. And it can easily use, so there is no need for storage. But there is some challenges. Number one is logistic challenges, because this is very time consuming. So there are lots of people need to address at the same time and requires a limited window for use after preparation. I mean, after using one time, we cannot use it again. And for frozen FMT, in these cases, donor feces are processed and stored at low temperature at first. It has some advantage, especially we can store and we can use when we need it. So it's ready to use basically, and allows for the establishment of stool banks. So we can make some stool bank using frozen sample that I have shown in our study also. And there's some challenges, is that the freezing and thawing can reduce the viability of some species. So if we store a long time, the microbial diversity or microbial viability can be lower. And another disadvantage is we need very specialized equipment, refrigerator for storage. Beyond fresh and frozen, there are other technique also for FMT formulation. For example, freeze dry and capsule formation. So in freeze dry cases, the fecal material is freeze dry and the water content is removed. So it's very easy to storage. Sorry, maybe in last slide I said we are using frozen. Basically, we are using freeze dry. We have another study that we use frozen. So in our latest study, we have basically used freeze dry. And this is very easy to transport because we can store this freeze dry sample in very normal, even in normal temperature. But it has challenges, especially um, it's it's take very sophisticated processing method to ensure the survival of the beneficial microbes. And maybe some microbes cannot survive during freeze dry process or freeze dry process. And the fourth formulation is tablet capsule format that is basically used for human cases. And its most important benefit is that it's freeze dry and it's non-invasive, easily shallow, and it's friendly for human users. And its major challenges is basically capsule integrity, ensuring the capsule protect microbiota from the stomach and deliver them into the intestine. Basically, this FMT works on large intestine. But if we use if we use capsule, it will at first go stomach, then small intestine, then in large intestine. So we need a special formulation to make it stable to rest in the body. So from the last overall slide, we have said about the importance of FMT, how FMT is different from antibiotics, and how FMT works. Then we have discussed about our latest research and I said how we overcome and to ensure that FMT can be can be used in cross area cases. So donor from one area can be used for another area. And finally, we have shown different types of formulation availability for designing donor FMT. So now I am discussing in the final talking about what types of thing we need to consider for making FMT very convenient and very effective, and especially how doctor or veterinarian doctor or farmers should use FMT very confidently. As because it's not clinically used in calf diarrhea treatment, but in our most research we have successful to show that FMT can be used confidently. However, still we need to consider some more concern about FMT. For example, donor selection. So donor animals should be healthy, and there should be no history of infectious disease or antibiotic uses, and they should high microbial diversity. So if we can ensure these three parameters and we can select donor, so there is a chance of successful donor cases. FMT formulations. So how we will use the FMT, either fresh or frozen or freeze dry. So depending on your availability and your laboratory equipment availability, you can decide uh, the major technique or best formulation technique you can consider. We have find out that the FMT is successful over 70% even in fresh or frozen or lyophilized. And how they should be administered into the body. However, in animal cases, basically rectal administration is convenient. And the final is preparation and dosages. So how much fecal volume you will consider for FMT? Generally, in our study, we have shown that at least 10 gram feces is uh, enough for getting positive response, successful response. So I think if you consider FMT for calf diarrhea, at least 10 gram feces should be collected, should be maintained. And safety and monitoring, obviously, it's a very important part. You should everyone should consider the post FMT period. They should check the calf status after FMT. Regulatory and ethical consideration. So this is very important, especially every institution has their ethical parameter. So for doing FMT in animal, you should consider the ethical guidelines. Efficacy and research. Still, we need more research to investigate how to get 100% efficacy or more than 90% FMT efficacy. And we have to think about the mechanism of how FMT works and how we can get the successful FMT. And logistic and implementation. So it is basically coming from successful plan. If we can make everything positive, then we can protocol, or we can make some SOP for making FMT successful. So right now in Japan, we are the one group only performing FMT. I mean, as far as we know, we are performing FMT, and we are now trying to make some SOP or guidelines how to use, how to make, how to select donor, how to optimize fecal sample, how to storage, and how to transport. So if we can make this SOP for a large number on the based on a large number of sample, I think the uses of FMT will be much more popular in future. And the most last thing is the cost and resource. So obviously we have to think about the cost. The antibiotics is commonly used, and veterinarian doctors or even farmer, they are very convenient. They are very very easy mindset to use the antibiotics. But in FMT cases, it still takes some resource, some cost. So if we can design a best FMT protocol or best FMT formulation, and we can make it readily available for the farmer, then the number of FMT users can be increased. So finally, by carefully considering all these factors, FMT can be effectively utilized as a treatment for calf diarrhea, potentially improving healthy outcomes and reducing reliance on antibiotics and other conventional treatments. So this is my overall talking about my FMT. So I will be very pleased if you have any comments or any questions. However, I have made some video recording my talking, so maybe in some cases, some word can be overlapped. I am very sorry for that. But if you still need more information, if you want to know more about me, you can freely ask me, or you can send me email anytime so we can discuss. And we want to make FMT very easy to available. So now I hope if you are very interested, if you have any thinking, if you have any idea, you can share with me. So thanks everyone, and I am waiting for your question or comments. Thank you again.
Thank you very much, Dr. Jahidul Islam, for the very inspiring and informative class about fecal microbiome transplantation. I am sure that the summer course participants have gained novel knowledge and higher awareness of the importance of animal livestock well-being. Please give a hand of applause for Dr. Jahidul Islam once again. We will now start the question and answer sessions. There will be 2 sessions, each with 2 questions from the participants. We expect your active participations in these Q&A sessions. Before asking your question, please state your name and country of origin. Those of you who are on site, please raise your hands and stand up. Online participants can push the raise your hands button on the Zoom and unmute your mic when asked, or type your questions in the chat. Okay, let us first welcome Dr. Jahidul Islam. Doctor, can you hear us loud and clear? Oh, the organizing committee, please unmute the mic. Can you help him unmute the mic, please? Hello, Dr. Jahidul Islam. Good afternoon. Greetings from Indonesia. Can you hear us loud and clear?
Yes. Good afternoon, everyone.
Okay.
Can you hear me?
Yes, we can hear you.
Thank you.
Okay. So let us begin the first Q&A sessions. Anyone who wants to ask questions, please raise your hand. Okay. We have Mr. Abu here from Pakistan. Can you turn on the mic? Test the mic first.
Hello.
Okay. Please state your name and country of origins, please, and state your question.
Okay. Good afternoon, and my name is Abu Huraira. I am from Pakistan. So I had one confusion. First of all, as you explained the environmental impacts of livestock industry. So my question, first of all, is it's actually a confusion that how is deforestation directly related to increased population of livestock? And second, my question is that in the unsuccessful FMTs, were there any negative outcomes or not? So these are my 2 main questions. Thank you.
Thank you very much. So I will answer your last comments. So what happened if we failed, right?
Yes.
Okay. So yes, we have still faced some challenges if we to recover the diarrhea using FMT technique. So sometimes the calf condition is very severe, and their clinical outcome is become very slow, and some cases they are die even though we are given FMT. So one thing is if it too severe and they can be die. It's not for giving FMT, but it's their own physical condition. Their severity is very high. And in your first question, you said how the deforestation. Yeah, now it's not uh, exactly in my research topics, but generally, if we want to use calf farming, there are two way or several way for calf farming. One is open area, another is closed area. So in open area, generally the calf are raised openly. So especially for example in New Zealand, they are raised in some island. Although they are directly not related to deforestation, but is another challenge for making large area for raising the calves, to not to give them stress, to lead them a stress-free life. They are raised in open environment or open area. So I think it's a major challenge in some country. Those have not that type of space. So this is my comments, I think.
Okay, so one more thing related to the second question is that is it absolutely necessary to for the successful FMTs that for the long term that the intake of prebiotics and probiotics is it absolutely necessary or no for the long term solution after the successful FMTs?
So now there are many ways to raise the calves or given milk replacer or given nutrients, probiotics. Many groups are now doing research. They are making uh, something there. But in our case, we are thinking that FMT works well. So after it become healthy, so you can give it anything, any food or any normal vitamins or nutrients. So after if it healthy, so you can give any probiotics or prebiotics for its betterment. Yes, so that's my answer.
I got my answers and thank you so much.
Thank you.
Okay, thank you. We have one more question for this first session. If you want to ask your question, please state your name and your country of origin, please. Maybe someone from the chat, from the virtual participants. Okay. If no one wants to ask, maybe I can ask first, Dr. Jahidul Islam. I'm curious about something.
Yes.
In a case where untreated calves with high case of diarrhea survive to adult cows, are there health problems in the adult cows?
Generally in FMT, we are introduced FMT young calves, right? Very pre-weaning calves. So at the young calves, it's very easy to change their microbiome. But in adult cow, it is very tough to change their microbiome because the microbiome is already established. So FMT works very well in the young calves. So if we think we want to use for adult, it will be a different types of research. But in context of microbiome, I think there in adult cow the microbiome change is very tough because they have already established rumen microbiome, everything. So young calves is better to use FMT.
Okay, then. Maybe other participants, any questions? Oh, someone here? Okay, please state your name and country of origin. Thank you. Do you need the mic? Maybe you can borrow my mic. Okay.
Assalamu alaikum. I am Baha from Bangladesh.
Oh, okay.
Thank you so much for your nice presentation. So we show that after this study to control diarrheal disease, applied FMT. So this study in Japan. So my question is how management level like in Bangladesh or compare with Japan. So their management level is different. So what will be your suggestion for applying this FMT to different countries like subtropical countries like Bangladesh, Indonesia, Thailand? So this is my question. Thank you.
Yes, thank you. Thank you for your nice comments. Yes, it's very, now we are successful in Japan. So, and a good thing is we are now continuing our research, not only in Japan, we are trying to introduce FMT in New Zealand and even in Indonesia in future, in this year. But you know, there are some rules and biological regulations. For example, this is fecal sample, and they have some pathogen, they have some virus, they have some bacteria. So directly, we cannot use, for example, Japanese cow FMT to the Indonesia or Bangladesh or other country. So what we are not doing, we are trying to establish in own country. For example, in our latest another research, we have jointly doing research in New Zealand. But interesting thing, in New Zealand and in Japan, they're raising the farming condition is different. Even if I think Indonesia or even Bangladesh, they're raising cow farming and doctors viewing is still different. But we are trying to introduce this concept. So, for example, in Bangladesh, if we want to introduce this technique, so we need more research result. So in this slide, sorry, I did not show my publication. So we have a very, very good publication in our FMT that published in Microbiome Journal, and its impact factor is 15, more than 15. So now the different veterinarian doctor from different country, they will be interested and they will understand that, yes, this is another way to use FMT. So I think maybe in future, we want to establish FMT in every countries based on their rules and regulation. So if we can make some collaboration, if we can make some group that they can introduce FMT in their own country, so that will be interesting. So in near future, as I'm a Bangladeshi person, I'm very interested to use this technique in Bangladesh also. Yes. Thank you.
Does that answer your question? Okay. Great.
Okay, thank you so much.
Okay, so we will begin the second session for the Q&A sessions. We will have, due to the time limit, I think we can only have one more questions. Anyone from the on-site participants or maybe virtual? Anyone? Okay. Maybe one more question from me. Oh, yeah. Okay, we have one more here. Please state your name and country.
Hello, good morning. I'm Gio from the Philippines. I'm just wondering what influences the percentage of likelihood of success or failure for FMT?
Sir, are you still? Oh, okay. The host, maybe can you help us unmute the mic again? Okay.
Sorry. Okay. I'm sorry. Can you say one more time? I'm sorry. I'm just.
Can you repeat the question, please?
My question was that what factors influence the likelihood of success for FMT? Like why
Yes.
are there failures? Yeah.
Yes. Thanks. This is very our one of our research of interest. So now we are trying to predict FMT success. I mean, how we can be succeed before giving FMT. So right now we are making some guideline and to make to present some of the bacteria that are present in the recipient. For example, Sporobacter. So if we somehow identify Sporobacter in the recipient, there is a chance that this calf will be succeed. So this is our one way to make prediction of FMT success before giving FMT. But in some cases, we have to remember that this is we are doing research on clinical sample. So that means they have their genome, their systemic systemic factor, their microbiome factor, their farming factor, their area factor can affect this result. So, however, based on this prediction of Sporobacter presence, we can ensure there is a high chance of successful.
And may I add, what are the possible sources of error for this kind of procedure?
Sorry.
Sources of error. How can you, like, why are there failures?
Okay. Yes, I said that there may be some of the cases the calf condition is very severe. If they have multiple pathogen at the same time, for example, some calf they are affected by only bacteria, but some calf they are affected by not only bacteria, but bacteria, virus, protozoa, and at the same time, they have some poor immunity. So yeah, in these cases, maybe our technique can be failed. Yeah.
Okay, thank you so much, Dr. Jahidul Islam.
Thank you.
Okay, due to the limit time restraints, that was our last questions for the first sessions. Once again, thank you, Dr. Jahidul Islam, for the presentations. With the last question answered, I would like to close the first session and invite back the MCs to continue today's event. And for the last time, let us give another round of applause for Dr. Jahidul Islam.
Thank you. Thank you, everyone.
Thank you so much for Dr. Jahidul Islam for insightful lecture about fecal microbiota transplantation for livestock animal being. We would like to give the appreciation certificate to Dr. Jahidul Islam by symbolize. Please give a big applause to Mr. Jahidul Islam for amazing material.
And also, we would like to thank you to Putrika Cita, Master of Science, who had led the discussion before, and certificate for Putrika Cita, Master of Science, will be given by the chairman of the 6th Sustainable Agroindustrial Sector Summer Course Program, Dr. Agung Putra Pamungkas. The certificate will be given by Symbolize.
Thank you very much.
Yeah.
With the session of appreciation certificate and already implemented, then the first material of this summer course has ended, and for operators, you may stop the recording for the first session. Thank you. We